Today we're going to work on a few skills related to decimals. This is not all in your term notebook because some of it's review and then some of it's maybe new, so we will put some of it there. I will let you know when we do that. But for now, you may just want to have a piece of notebook paper out to write down some examples. So we're going to start by practicing how to read decimals. Sometimes people have a hard time with the place value words, and I have a trick for that. To read decimals, put a 1 under the decimal and a 0 under each place after to find the place value word. Remember, the decimal always says and. So when we look at this, we read this as 2 and 4, and then our place value word comes from where we put the 1 under the decimal and then the zeros under each place after the decimal. So that's why it's hundredths. So this one says 2 and 4 hundredths. Let's look at a couple more of these. So this next one, our example here is going to say 7 and, the decimal says and, so 7 and the number after the decimal is 25. If I just look at the part after the decimal, I could read that as 25. So it's 7 and 25 10,000ths, because if I put a 1 under the decimal, a 0 under each place after, then my place value word is 10,000ths. So this one says 7 and 25 10,000ths. For my next example, I don't have to say the 0. I can if I want to, but I don't have to. I typically don't. So this one, I just say the part after the decimal and then the place value word. So this one says 286 thousandths, 286 thousandths. And last but not least, that one's going to say 2 and 560 thousandths. Thousandths is going to be my place value word when I put my 1 under the decimal and a 0 under each place after. So that says 2 and 560 thousandths. And I know some of you are saying, well, couldn't I read that as 2 and 56 hundredths? Well, only if it looked like this. So those two that would say 2 and 56 hundredths. And yes, those two are equal. However, we wouldn't call them the same. We wouldn't read them out the same way because they're not written the same way. This trick is also really useful for telling what place a number is in. For example, if I looked at the 286 thousandths, I could easily see that the number in the tenths place is the 2, because I can just make it say 10, put a 1 under the decimal is just 1 0, and the number above it is in the tenths place. So the 2 is in the tenths place, the 8 is in the hundredths place, the 6 is in the thousandths place. In the number 2 and 560 thousandths, the 5 is in the tenths place, the 6 is in the hundredths place, and the 0 is in the thousandths place. So I can use this trick for multiple purposes, really. Now, let's talk about comparing and ordering decimals. So if I want to compare and order decimals, the first thing I need to do is rewrite all the numbers, being sure to line up the decimals. And then I annex. That means add zeros if needed, so that all the numbers have the same number of places after the decimal. Then step 3 is to compare the whole numbers, that's the part before the decimal, and then compare the decimals, that's the part after the decimal. So let's look at that in action. So it says put these numbers in order from least to greatest. So I'm going to start by rewriting them so that the decimals are lined up with each other. And it's nice to line up your digits as well, so that they're one on top of the other. And if you needed to, you could take a piece of notebook paper and turn your paper sideways so that you could use the lines to help you line everything up as well. That's really, really helpful, especially if you have a hard time just lining them up on your own. Now, when I look at these, before I start comparing, I want to make every one of these have the same number of places after the decimal. So right now, the first number has 2 places, the second one has 3, the third one has 3, and the last one has 1. So I need to make them all have 3. So, because I can't just cut anything off of anything. So the only thing I can do is add zeros. Adding zeros to the end does not change the value of the decimal because the zeros are after the decimal. So I'm going to need 1 0 here, and I'm going to need 2 zeros here. Then I can start comparing. I'm going to start by comparing the whole numbers. The whole numbers are all 9. They're all the same, so that means that that's not going to help me I can't put them in order based on the whole number part. So then I look at the part just after the decimal. And I know some of you are used to doing this. Some of you are used to looking at the number in the tenths place and comparing those, then the numbers in the hundredths place, this and that. And you can do that, but I'm going to suggest to you that I think it's easier. We want to go least to greatest. I think it's easier, and the reason why I have you annex the zeros is because now I can just look at this and say, well, if I want to go least to greatest, then I look, and that first one has 60 thousandths, then 76 thousandths, then 66 thousandths, then 600 thousandths. So all I have to do is put those numbers in order. So 60, 66, 76, 600. So when I want to put the numbers in order, I can say, well, my first one is 9 and 600ths, then 9 and 66 thousandths, then 9 and 76 thousandths, then 9 and 6/10. And the reason why we're annexing those zeros is because think about this for just a minute. If I thought about these as fractions, couldn't I say that 9 and 600ths, the decimal, equals 9 and 600ths as a mixed number? 9 and 76 thousandths equals 9 and 76 thousandths. We wouldn't typically compare those very easily because they don't have the same denominator. When I annex that zero, what I'm really doing is it's like finding a common denominator. So 9 and 600ths becomes 9 and 60 thousandths, which is 9 and 60 thousandths. And that makes it a lot easier to see why this annexing zeros really becomes helpful, because 9 and 66 thousandths, 9 and 600 thousandths. So that basically makes it like fractions, make them so they're like fractions, so they have the same denominator. All right, let's look at another example. So this time we want to put our numbers in order, and we're going to put them in order from, it's really important to pay attention to this, greatest to least this time. So 14 and 23 hundredths, 13 and 95 hundredths, or the first one was 14 and 23 thousandths rather. Then we have 13 and 95 hundredths, 14 and 2/10ths, 14 and 9 thousandths. I'm going to need to have 3 places after the decimal for all of them because that's the most any of them have. So I'm going to annex a 0 here, and I'm going to annex 2 zeros here. And now this makes this easier to compare. We want to go from greatest to least. Well, I can quickly look and see this one has to be the least because it has 13 as the whole number and the others have 14. So this is definitely number 4. Then I'm going to look at just the part after the decimal. So looking at just the part after the decimal, we've already used the 950, so we can't use that again. So from greatest to least, we're going to go 200, then 23, then 9. And so our answer then here is going to be, from greatest to least, is going to be 14 and 2/10ths, 14 and 23 thousandths, 14 and 9 thousandths, and last but not least, 13 and 95 hundredths. All right, so again, that idea of annexing zeros, that's really going to be the thing that makes this the easiest probably. And again, the reason that makes sense is because it's very similar to finding like fractions, which once we have like fractions, then it's easy to just compare the numerators. So once we make these have the same number of places after the decimal, then it's easy to just compare the number that's after the decimal. All right, the last thing we want to look at is changing decimals to fractions. And I kind of already hinted at what we would do with this. So when we want to change a decimal to a fraction, first thing we need to do the 3 R's: read, write, reduce. So read the number, and remember the hint of putting a 1 under the decimal to help you. Then write the fraction, and then reduce or simplify. So when I look at this first example, I put a 1 under the decimal, a 0 under each place after. It's pretty easy to see that that says 28. So I've read it as 28 thousandths. Now I'm going to write it, or hundredths rather. Now I'm going to write it as 28 hundredths. And then I'm going to simplify it. 28 and 100 can both be divided by 4 to give me 7/25. So 28 hundredths the decimal equals 28 hundredths the fraction, which simplifies to 7/25. All right, let's look at a couple more examples. So this one says, when I put a 1 under the decimal and a 0 under each place after, it says 5 and 26 hundredths, but I'm going to write it as the mixed number 5 and 26 hundredths. 26 and 100 can both be divided by 2, so I'm going to simplify this to 5 and 13/50ths, which is in lowest terms. For my next one, again, the whole number I can just copy, and that's going to make it a mixed number. So 2 and 125, now I just need the denominator. A 1 under the 0, or 1 under the decimal, 0 under each place after. Notice if I put the line there, that really makes my mixed number. 2 and 125 thousandths. Now you might be saying, ooh, that's going to be hard to simplify. Well, maybe, maybe not. There are lots of numbers that go into both 125 and 1,000. 5 might be the easiest one for you to think of. If I were to divide those both by 5, I'm going to get 2 and 25 200ths. 25 and 200 can still both be divided by 5. They could also be divided by 25. And when I do that, I'm going to get 2 and 1/8. So 2 and 125 thousandths equals 2 and 1/8. One more example. So this one is going to say 7. When I read it, I'm going to put my 1 under my decimal, my 0 under each place afterward. That helps me read it as 7 and 45 hundredths. So I'm going to write it as 7 and 45 hundredths. And then I'm going to reduce or simplify. 45 and 100 can both be divided by 5, giving me 7 and 9/20ths. So my answer for this one is going to be 7 and 9/20ths. A lot of this was hopefully review for you. Some of it, particularly that part about changing the decimals into fractions. And by the way, I should have told you that that's the part where we're going to have it do it in your term notebook. It's on page 64. So if you needed to go back and do that, please go back and do that. I'm sorry, I forgot to tell you sooner, but that's where you're going to write those notes. So if you need to rewind to write that in, go ahead and do that. And then the last thing that I want to share with you is that there are some common fraction decimal equivalencies. And so I want you to copy those down in your term notebook. You've got space to copy that on page 64. And copy it just like this. And you may not know quite what those lines over the 3 and the 6 mean yet, but you're going to find that out. I will explain that to you. So copy it just the way that it is. But these are some really common fractions, and it's important to know what decimals they equal so that you can quickly and easily go back and forth between them without necessarily having to do the work to go with it because you just have it memorized.